Hey class, this is the third video for our ionic bonding video series, and this time we're talking about transition metals. I know, those guys that are a complete pain in the butt, but we still have to learn about them. Now, the first thing you have to do, just like before, you have to find which two elements you're bonding, and then you have to find their symbols. So first up we have iron 3, and we'll get to that in a second, and oxygen. So find iron's symbol. Right over there in the transition metals, top period, is Fe. Now the reason transition metals can get kind of confusing is because their oxidation numbers are not predictable. But that also works in our favor because they have to be given to us, the oxidation numbers that is. And they're going to be given to us in the form of Roman numerals. So iron 3, that 3 tells us that iron's oxidation number is a 3. And it's a metal, so it's going to lose electrons, so 3+. As far as the nonmetal go, same process as before. Oxygen, we know its symbol is O. And it's in group 6A, meaning it's going to gain 2 electrons because it's easier to do that than to lose 6. So 2, and it's a nonmetal. Gaining electrons makes it negative. And then last step, crisscross applesauce. 2 goes to iron, 3 goes to oxygen, and we end up with Fe2O3. Same as before when it comes to the final product. The only difference, using that Roman numeral for our oxidation number. Let's look at a second example. Tin4 plus sulfur. Okay, well, if you find tin on the periodic table, it's got kind of a weird symbol, but it's Sn. And then it tells us 4. Same as before, except it's a 4 positive and not a 3 positive. Now find sulfur, just S. It's in group 6A as well, so it's going to gain 2 electrons. Makes it a 2-. Now, last step, crisscross applesauce. 2 goes to tin, 4 goes to sulfur, and you end up with Sn2S4. But what did we say earlier on the last video about reducing common numbers? Let's get it in the most simple form. So 2 to 4 is the same as 1 to 2. So our final correct formula would be SnS2. All right, last one. Zinc 2 plus bromine. Now, zinc is unique because it's always going to be a +2. But I'll still give it to you when it comes to tests and quizzes. So zinc, if you find its symbol on the periodic table, is a Zn. And we know it's 2 positive. All right, how about bromine? Bromine's over there in group 7A. So it has 7 valence electrons. Its symbol is Br. And it's going to gain 1 electron to fill its octet. So 1, and we know if we gain, it's a negative. Last step, crisscross applesauce. 1 goes to zinc, 2 goes to bromine. We end up with zinc 1, bromine 2. So ZnBr2. Okay, we're 3/4 of the way there. Now we're going to come back and learn how to name these transition compounds in the next video.